This is a fictional story created for the purpose of explaining outlier analysis. Any resemblance to real data, people, organizations, or events is purely coincidental. Police sirens pierced the night as flashing lights bathed the street in red and blue. A car lay wrecked against a storefront, glass scattered across the sidewalk. Officers quickly moved in, cordoning off the scene beneath the flickering glow of a lone streetlight. It looked like a simple accident, but something wasn't right. The crime scene unit moved with quiet precision, their gloved hands sweeping fragments of shattered glass into labeled evidence bags dot to the trained eye. Everything seemed standard, just another crash site, business as usual. Until it wasn't. The forensic department started analyzing the glass fragments with spectral and density scanners. Screens flicker to life with precise readings, refractive indices, elemental compositions, density profiles. Each fragment reveals its story in data. The data for the glass pieces is shown here. It contains refractive as well as chemical composition of the glass. The data has many chemical properties of the glass, such as sodium, magnesium, potassium, and other properties. The data scientists of the forensic department analyze the data. They use outlier detection algorithm isolation forest. As the data unfolds, something breaks away from the pattern. A few glass fragments stand out, flagged by outlier analysis. They're chemically distinct, denser, with unusual refractive properties. A scatter plot confirms their separation. Then comes the radar chart, a fingerprint of anomalies. It is interpretation of isolation forest outlier analysis. Radar chart helps understand what differentiates between an outlier and not outlier. Refractive index, iron, barium, potassium. The profile is clear, but not conclusive. To go deeper, a machine learning model is deployed, treating outliers as the target. Machine learning helps to understand top factors causing the outlier. The result? Two major clues rise above the rest: refractive index and potassium. And most telling of all, the outliers have an unusually high potassium signature. This wasn't just random glass. This was planted or brought here for a reason. Further investigation confirms the anomaly. These aren't automotive or architectural glass. They are container glass, foreign to the crash site. And now, the question shifts from what happened to why was this here. The glass containers found at the crash site weren't just debris. They were evidence being moved, hidden, tampered with. The so-called accident wasn't an accident at all. It was a cover-up. The containers told the truth. And the outliers? They cracked the case wide open. Let us now see the analytics used in cracking the case. The following analytics have been used: isolation forest to detect outliers, radar chart to see factors which differentiate an outlier, and machine learning to identify the top factors contributing to outliers. Let us see how this analytics work, and let us start with isolation forest. The premise of the isolation forest algorithm is that anomalous data points are easier to isolate from the rest of the sample. Let's say we have data points with value 1 to 5, and we have an outlier with value 15. If I make a partition between 5 and 15, then the outlier is separated just with one single partition. However, for non-outlier points, it's not easy to isolate them. For example, if I place a partition between 2 and 3, I cannot isolate any points. I can try again by putting partition between 3 and 4, or between 4 and 5. Still, I will not be able to isolate the non-outlier points. So in short, if a point gets easily isolated, it is an outlier. In a multi-dimensional data, the algorithm recursively generates partitions on the sample by randomly selecting an attribute, and then randomly selecting a split value between the minimum and maximum values allowed for that attribute. Isolation forest will mark each data point as an outlier or not. Then, we can use a radar chart to compare the values between outliers and non-outliers. This gives us a clear visual of how each feature behaves across the two groups. If certain dimensions spike or drop sharply for outliers, it helps us understand what makes them stand out. Though the radar chart is visually very useful for spotting which factors may be driving the outliers, it doesn't tell us which feature is more important than the others. For that, we can turn to machine learning. We treat all the characteristics as features and the outlier label as the target. The machine learning model then learns patterns in the data and tells us which characteristics have the most influence on whether a point is an outlier or not. You can try out outlier analysis on our platform experience datascience.com. No coding is required, and you can work with your data. Please do subscribe to the channel, and see you soon in another video.